Let's take a look at this example here. And this is a continuation of our geometry notes 3-5, the polygon sum theorem. So if we have a polygon that has 26 sides and we're asked to find the sum of the interior and find the sum of the exterior, well, the easy one is this one right here. The exterior, sorry about that, the sum of our exterior is simply 180 degrees. Always will be, no doubt. And when it comes to the sum of our interior, well, that's going to be n, which in this case, n equals 26. It's a 26gon. So 26 minus 2 times 180. The 26 minus 2 gives us the number of triangles. There would be 24 triangles if you drew a diagonal from one vertice to all the others. If we put that in our calculator, believe it or not, we'll get 4,320 degrees on the inside. We can do the same thing for a 50gon, answering the easy one, the sum of our exterior. Just have to have it memorized. Exterior is going to be 180. Whereas the interior, we're going to do the same thing we did the last time. We're going to take our m, which is 50, subtract 2 from it, put that in our calculator, and given that that would give us 48 triangles, each of them with 180 degrees, we'll end up with 8,640 degrees on the inside. Let's take a look at another type of problem that's involved with these, and that's when we're given several angles and we need to find the missing angles. Okay? We did some of these with triangles, but this time we have polygons that we're going to have to calculate the sum of the interior angles first before we do the little manipulation we did with for our triangle. So again, let's take a look at our interior angles here. The sum of all of the interior angles here will be 1, 2, 3, 4 sides, 4 minus 2 times 180, which would be 2 times 180 or 360 degrees. So now we know what the sum of all of these will be. That's going to be 360. So to find x, well, we know that all 4 of these, the 71 plus the 112 plus the 48 plus the x, would equal 360. Or we would know by doing our math here, 360 minus these 3, 71 plus 112 plus 48, would give us the amount of degrees that x is. This would be 360 minus 231, or 129 degrees. Now that we know that this one is 129 degrees, we can find our exterior angle from this. Exterior angles are really simple. They're just going to be 180 degrees minus the measure of the corresponding interior angles. These are linear pairs. They sum to 180, so when we subtract this, this will give us a 51 degrees on the inside. Let's take a look at our next one. Start out by finding what the sum is. This is not a triangle. The sum of the interior is not going to be 180, but let's count them. 1, 2, 3, 4, 5, 6. 6 minus 2 times 180 would give us a 720 degrees for the sum of these. That means to find the value of x, this interior one, we would have to take 720 and subtract all of these. The 130, the 93, the 150, the 124, and don't forget this guy right here is a right angle. It's 90 degrees. If you put that in your calculator, you'll get 720 minus 587, or 133 degrees for this guy right here. In this particular problem, we don't need to have x in order to find y. If we wanted to, we could find y first. It's simply going to be associated with this interior angle. Those two are a linear pair, which means y would equal 180 minus 130, or 50 degrees. And let's take a look at our next one. In this one, our sum is going to be, let's count them up, 1, 2, 3, 4, 5, minus 2 times 180, which is going to give us 540 degrees as our sum. X is this interior angle here. So if we take that total of 540 and subtract the sum of the 160, the 100, the 80, and the 91, we will get a 109-degree angle on the inside. And as we've done on the last ones, in order to find the exterior angle, y in this case, we subtract the corresponding interior angle, which we've calculated at 108, from that, and we get a 71-degree angle. Now be careful, this one also has a third variable to find, and that is z. This one's similar to the last one. We don't need to know x, nor do we need to know y. In order to find z, we just take the corresponding interior angle of 80, subtract it from 180, and z is going to equal 100 degrees. Now, we have a special case here we want to look at, and that is if we have a polygon that is regular. Okay. Now, I want to remind you, if you want to look back in your notes, when we and the Desmos activity, regular means that all sides are congruent and all of the angles are also congruent. Okay. Now, if all of the angles, we're referring to the interior angles, are all the same, then that would mean the corresponding exterior angles are all going to be the same. Okay? So, if I have a regular polygon, not only will the interior angles be the same, but all of the exterior angles will be the same or congruent to each other. Okay? So in this example it says, hey, we tore off an edge of a 35-sided polygon. It's shown over here. And it says, what would we do to find just one of these interior angles? What would just one of these, not all 35, but just one of those measure to be? And let's think about this. If we want to find just one of these interior angles, then all we have to do is, one of these exterior angles. One exterior angle. Well, think about it. If we found and knew the sum of all exterior angles, and we divided it by the number of exterior angles, that's going to give us what one of these angles measures. Because again, they're all the same. Now, think back to what we talked about on the previous page. We know the sum of the exterior is always going to be 180. I'm sorry, I said 180, and that should be 360. The sum of our exterior angles is always 360. Okay? So, since that's always 360, in this case we have 35 angles on the outside. If we take 360, divide it by 35, That means each one of these, not only the 35th one, but even the first one, those would measure 360 divided by 35 is 10.285 degrees. This one would be 10.285 degrees. If you don't believe me, take 10.285, multiply it by 35, and I guarantee you'll get 360. Okay. Now, the next one is related to this, and it says, okay, if that's the exterior, let's find out what one interior is. Well, that's really simple. That's just going to be, so one interior angle. Remember, these are linear pairs. It's simply going to be 180 minus what we just got right there, the 10.285 for the exterior. If you put that in your calculator, that's going to give you 169.715 degrees. Okay. Let's do two more examples just so you understand. If we have a regular, remember it has to be regular for us to do this little manipulation. If we have 15 sides of a polygon, if it is regular, all of the angles are going to be congruent. All of the exterior angles are congruent. So, to find one exterior angle, we're going to take 360 divided by 15 and get 24 degrees as the exterior angle. So if I were looking at an edge of this and we had 15 other sides on it, this exterior angle here would be 24 degrees. So to find the measure of this interior angle, we're just simply going to take, and this is just one of them, one interior angle, we're going to take 180 and subtract 24, and we'll get a 156 degree angle. Let's do one more example just to make sure we understand this. Key, regular, all angles congruent. Exterior, only one of them. One exterior angle will be 360 divided by 12, or a 30 degree angle. That is, again, if I tore off the edge, this exterior angle here is going to be 30 degrees. If I tore off another edge, it would still be 30 degrees. Those are the measure of all of the exterior angles. And each one of the interior angles then, because these form this linear pair, they are a linear pair, they form this straight line, the interior angle here, just one of the interior, will be 180 minus the 30, or a 150 degree angle. Okay. So go ahead and finish your homework, and you'll find that you'll need to use this and the other stuff that was provided in this lesson, and hopefully all of that will make sense. If not, you're welcome to come back to this video and review this one more time. Have a good day.